Okay, I am going to start the volcano reading on page 323. Everything prior to this was in the prior unit also. Hotspots. Not all volcanoes develop along plate boundaries. Areas of volcanism within the interiors of the lithospheric plate are called hotspots. Most hotspots form where columns of solid hot material from the deep mantle, called mantle plumes, rise and reach the lithosphere. When the mantle plumes reach the lithosphere, the plume spreads out. As magma rises to the surface, it breaks through the overlying crust. Volcanoes then form in the interior of the tectonic plate, shown in Figure 5. Mantle plumes appear to remain nearly stationary. However, the lithospheric plate above the mantle plume continues to drift slowly, so the volcano on the surface is eventually carried away from the mantle plume. The activity of the volcano stops because no hotspot that contains magma no longer feeds that volcano. However, a new volcano forms where the lithosphere has moved over the mantle plume. Other scientists think that the hotspots are a result of the crack of the Earth's crust. The theory argues that hotspot volcanoes occur in long chains because they form long cracks in the Earth's crust. Both theories may be correct. Intrusive activity. Because magma is less dense than solid rock, magma rises through the crust toward the surface. As the magma moves upward, it comes into contact with or intrudes the overlying rock. Because of the magma's high temperature, magma affects surrounding rock in a variety of ways. Magma may melt the surrounding rock or may change the rock. Magma may also fracture surrounding rock and cause fissures to form to cause the surrounding rock to break apart or fall into the magma. Rock that falls into the magma may eventually melt, or the rock may combine with the new igneous rock, which is rock that forms when the magma cools. When magma does not reach the Earth's surface, the magma may cool and solidify inside the crust. This process results in a large formation of igneous rocks called plutons, as shown in Figure 6. Plutons can vary greatly in size or shape. Small plutons, called dikes, are tubular in shape and may only be a few centimeters wide. Batholiths are large plutons that cover an area at least 100 kilometers square when they are exposed at the Earth's surface. Volcanic eruptions. Volcanoes can be thought of as the window into the Earth's interior. Lava that erupts from them provide an opportunity for scientists to study the nature of the Earth's crust and mantle. By analyzing the composition of the volcanic rocks, geologists have concluded that there are two types of magma. Mafic describes magma or rock that is rich in magnesium and iron and is commonly dark in color. Felsic describes magma or rock that is rich in light-colored silicate materials. Mafic rock commonly makes up oceanic crust, where felsic and mafic rock commonly make up continental crust. Types of eruptions. The viscosity or resistance to flow of magma affects the force with which the particular volcano will erupt. The viscosity of magma is determined by the magma's composition. Because mafic magmas produce runny lava that has a low viscosity, they typically cause quiet eruptions. Because felsic magma produce sticky lava that has a high viscosity, they typically cause explosive eruptions. Magma that contains large amounts of trapped, dissolved gases is more likely to produce explosive eruptions than magma that contains a small amount of dissolved gases. Quiet eruptions. Oceanic volcanoes commonly form from mafic magma. Because the mafic magma's low viscosity, gases can easily escape from the mafic magma. Eruptions from oceanic volcanoes, such as those in Hawaii, shown in Figure 1, are usually quiet. Lava flows. When mafic lava cools rapidly, a crust forms on the surface of the flow. If the lava continues to flow after the crust forms, The crust wrinkles to form volcanic rock called Pahoja Hoya, which is shown in Figure 2. Pahoja Hoya forms from hot fluid lava. As it cools, it forms a smooth, ropey texture. Pahoja Hoya actually means ropey in Hawaiian. If the crust deforms rapidly or grows too thick to form wrinkles, the surface breaks into jagged chunks to form aha. Aha forms from lava that has the same composition of Pahoja Hoya. Aha lava's texture results from differences in gas content in the rate and slope of the lava flow. Blocky lava has a higher silica content than aha lava does, which makes blocky lava more viscous than aha lava. The high viscosity causes the cool lava at the surface to break into large chunks, while the hot lava underneath continues to flow. This process gives lava flow a blocky appearance. Explosive eruptions. Unlike fluid lavas produced by oceanic volcanoes, the felsic lavas of continental volcanoes, such as Mount St. Helens, tend to be cooler and stickier. Felsic lava also contains a large amount of trapped gas, such as water vapor and carbon dioxide. When a volcano erupts, the dissolved gas within the lava escapes and sends molten and solid particles shooting into the air. So felsic lava tends to explode and throw pyroclastic materials into the air. Pyroclastic materials consist of fragments of rock that form during volcanic eruptions. Types of pyroclastic materials. Some pyroclastic materials form when magma breaks into fragments during an eruption because of rapidly expanding gases in magma. Other pyroclastic materials form when fragments of the erupting lava cool and solidify as they fly through the air. Scientists classify pyroclastic materials according to the size of the particles, as shown in Figure 3. Pyroclastic materials that are less than 2 millimeters in diameter are called volcanic ash. Volcanic ash is less than 0.25 millimeters in diameter is called volcanic dust. Most volcanic dust and ash settles to the land that immediately surround the volcanoes. However, some of the smallest dust particles may travel around the Earth in the upper atmosphere. Large pyroclastic materials that are less than 64 millimeters in diameter are called lapilli, which is from the Latin word that means little stones. Lapilli generally fall near the vent. Large clots of lava may be thrown out of an erupting volcano while they are red hot. As they spin through the air, they cool and develop round, spindle-shaped. These pyroclastic materials are called volcanic bombs. The largest pyroclastic material, known as volcanic blocks, form from the solid rock that is blasted from the vent. Some volcanic blocks are the size of small houses. Types of volcanoes. Volcanic activities produce a variety of characteristic features that form during both quiet and explosive eruptions. The lava and pyroclastic materials that are ejected during volcanic eruptions build up around the vent of the volcanic cones. Volcanic cones are classified as three types as described in Figure 1. The funnel-shaped pit at the top of the volcano is known as the crater. The crater forms when material is blown out of the volcano by explosions. A crater usually becomes wider as weathering and erosion breaks down the walls of the crater and allows loose materials to collapse into the vent. Sometimes a small cone forms within the crater. This formation occurs when subsequent eruptions causes material to build up around the vent. Types of volcanoes. Shield volcanoes. Volcanic cones that are broad at the base and have gently sloping sides are called shield volcanoes. The shield volcano covers a wide area and generally form from quiet eruptions. Layers of hot mafic lava flow out around the vent, harden and slowly build up to form the cone. The Hawaiian Islands form a chain of shield volcanoes that built up from the ocean floor at a hotspot. Cinder cones. A type of volcano that has generally steep slopes is a cinder cone. The slope angles of the cinder cones can be close to 40 degrees. The slopes are rarely more than a few hundred meters high. Cinder cones form from explosive eruptions that are made of pyroclastic materials. Composite volcanoes. Composite volcanoes are made of alternating layers of hardened lava and pyroclastic materials. During a quiet eruption, lava flows cover the sides of the cone. When an explosive eruption occurs, large amounts of pyroclastic materials are deposited around the vent. Explosive eruptions is followed again by a quiet lava flows. Composite cones, also known as stratovolcanoes, commonly develop to form large volcanic mountains. Calderas. When the magma chamber below a volcano empties, the volcanic cone may collapse and leave a large basin-shaped depression called a caldera. The process of caldera formation is shown in Figure 4. Eruptions that discharge large amounts of magma can also cause a caldera to form. Krakatoa, a volcanic island in Indonesia, is an example of this type of caldera. When the volcanic cone exploded in 1883, a caldera with a diameter of 6 kilometers formed. Calderas may later fill with water to form a lake. Thousands of years ago, the cone of Mount Mazuma in Oregon collapsed and formed a caldera. The caldera eventually filled with water and is now called Crater Lake. Predicting volcanic eruptions. A volcanic eruption can be one of the Earth's most destructive natural phenomena. Scientists such as those in Figure 5 look for a variety of events that may signal the beginning of an eruption. Earthquake activity. One of the most important warning signals of a volcanic eruption is changes in earthquake activity around a volcano. Growing pressure on the surrounding rocks from magma is moving upward causes small earthquakes. Temperature changes within the rocks and fracturing of the rock around the volcano also causes small earthquakes. An increase in the strength and frequency of earthquakes may be a signal that an eruption is about to occur. Patterns and activity. Before an eruption, an upward movement of magma beneath the surface may cause the surface of a volcano to bulge upward. Special instruments can measure small changes in the tilt of the ground surface in a volcano slope. Predicting the eruption of a particular volcano also requires some knowledge of its previous eruptions. Scientists compare the volcano's past behavior with current daily measurements of earthquakes, surface bulges, and changes in the amount and composition of the gases that volcanoes emit. Unfortunately, only a few active volcanoes in the world have been studied by scientists long enough to establish any activity patterns. Also, volcanoes have been dormant for a long period of time. Many, with little warning, suddenly become active.